I'm Pawel, and I'm super passionate about all of these features because I want to make sure that they're as awesome as they can be for you guys. So before I get into the presentation, scalable deployments and updates in Compute Engine, I just want to get a quick read of the room. How many people here are kind of new to compute in general? OK, it's about a quarter. And how many people are using compute but maybe aren't using managed infrastructure yet? So managed instance groups. OK, that's about a third. And then how many people are kind of like managed instance group experts, and you know them inside and out? OK, maybe like 15%. Good, good. It's a good mix. So let's talk about setting up infrastructure, serving infrastructure. And whether it's managed or otherwise, there's little point in setting it up if you don't get your software deployed to it. And then what you find is as soon as you get version 1 out there, there's probably a version 2, and then there's a version 3, 4, so on. In fact, some of our clients deploy software even multiple times a day. But these kinds of robust deployments of software to infrastructure that is hot and serving are only possible if you have the right tools. So that's why today I want to talk to you about how you can put together a serving infrastructure with the managed infrastructure features and get your software deployed onto it nicely and smoothly. And I built this presentation both for people who are kind of new to GC and those who are using GC but aren't using the managed pieces yet. And if you're a managed instance group expert, then hopefully you'll still get some value out of some of the new features that we'll be showing off. So let's start small. If you want to build a service from scratch, you might start with one server, and you just provision a virtual machine. And you might have given it some sort of a clever name. And then to deploy, you just log in and deploy your software. And when there's an update, it's not a problem. You just log in again and update it, and then that's fine. But even when then you have maybe 2 of these servers, or 3, 5, or 10, you can probably still manage because you can come up with like 10 clever names and log in to each one of them and deploy your software. And that's OK. And it's getting a little bit painful, but you can manage. But when you start getting into hundreds, thousands, or tens of thousands of servers, this manual approach really doesn't work anymore. And that's when you might have switched to some sort of a CI/CD system where suddenly your servers are these nameless, mindless drones, and they get spun up by other systems or by software, and now you don't have to worry about naming them, and they just get created. And that's really good, but when one of them goes down, you have to do something. Someone has to log in, and maybe it is actually literally you, to now restart this machine, recreate it. You have to take an action. Or if traffic dips, you suddenly have all these servers that are idle. And if you had a bad job and it finished, maybe all of the servers are idle. And that's why a managed instance group is this agent that monitors your servers for you and takes action on your behalf to do the right thing. Now, that's really vague. So let's break it down. Managed instance group has 4 major features. 1, there is the autoscaler. So that's the thing that people typically start with for MIGs. And the autoscaler can create and destroy machines for you based on load. And you can define what load means for you, whether that's CPU utilization or traffic, or with custom metrics, something completely different. There's the autohealer, which will recreate instances that become unhealthy and go down. And again, you can define what unhealthy means for your service with custom health checks. There's now one of the new features, the updater, which is currently in alpha, going to beta very shortly, which will help you deploy software to your managed instance group in a controlled manner in exactly the way you kind of need it and what works for your service. And there is regional, which will split your machines across different zones to make your service more available or move you towards high availability. So that's the 4 pieces. And the one thing to keep in mind with the managed instance group is that all of the pieces are integrated and they work well together, which is great. But more importantly, they're also modular, which means that if you don't need autoscaling, you actually don't have to take it. Managed instance groups are more than just groups of scaling machines. If you have a static work set, then you can have a MIG that maybe just uses auto-healing and updates, and it doesn't even use autoscaling. Or maybe you have zonal split with regional and updates, but you don't need auto-healing. And we'll dig into some of these features in detail throughout the presentation. So now let's talk about software, or more specifically, let's talk about the software lifecycle. And for purposes of this, let's break it down to something super simple. You write, you build, you test, and you deploy. And because it's a cycle, you do this over and over and over again. So let's say you built some software, and you decided to package it into a container, because containers are cool and stackable. But one of these containers. And now you have your container pack, and now you're thinking, I want to get it into the cloud. Well, it turns out there are a lot of options for how you actually can deploy your container into the cloud. On one end of the spectrum, you can go bare metal, and you can provision your own machine. You can install Docker, you can configure it, you can install the container, you can configure your networking, and you basically do all of this yourself, and that works OK. On the other end of the scale, you can go with the container engine, and you can ask us to provision a cluster for you. We'll manage the cluster for you. You then just upload your containers, and that works OK as well. In between the two, there is Kubernetes, where you basically take care of your own cluster, and you install Kubernetes on it, and the Kubernetes does the kind of scheduling of the containers. And now we're introducing this other option that is essentially a UI pass-through, where if all you need is to put one container on a machine, and you want some automation with that, well, we'll take care of some of the details so that you don't have to worry about setting it up yourself. So let me explain to you what that means. You still start by building your container and then uploading it to the container repository as normal. And then in the interface, when you go to create a new machine, there's a tick box which says that I want this instance to be containerized. And then you just pass a link to the container, open up whatever ports you need, give it to command line, and we'll take care of the rest. And what we do in the background is we'll provision the machine, grab the image that has Docker already pre-configured on it. It's the Google official Docker image. Put the container on it, run the command line, set up the networking the way you open it up, and that's kind of it. So for that really straightforward case where you just wrapped your software into a container, this could be an option. So let's take a look at what that looks like in practice with the new interface. So you start as you normally would with creating an instance. And let's give it a clever name so that we can potentially log into it later on. Put it into US Central. And here's the new pass-through where you can say, OK, well, now I want you to load this container, go over to the container repository, grab a link to it. And because this is a really simple front end, let's open up port 80. And now we have to tell the container launcher how to launch the container. So it's a script written in Python. So let's launch Python with front-end hc.py. And done. And that's it. And you can see that it's containerized with that little summary at the top. The machine is spinning up, and as soon as it gets provisioned, what will happen is, in the background, is, as I said, we'll basically load the container on and run the command that you passed us. OK, the machine is spun up and ready to go. And when you go into the machine, then you can see that it's containerized at, in the details. There's a link to the container that was preloaded on it. And if we go to the actual IP address for the machine, give it a second to refresh. And there you go. It's serving the super simple front end, healthy true, and deployment done. OK. So that worked really well for that simple case we talked about. We have one machine, and it's set up, and it loaded the container with basically just a little pass-through. Great. Now if we have a managed instance group, we want to be able to create multiple machines, because that one machine might not be enough, right? So maybe you need 2, 3, 10, 15 of them. But before you can create the group, what you need to do is describe how to create these machines. So the MIG needs a recipe or a template which will explain or which will allow it to provision the machines for you, right? Because the whole point is that now it's the MIG that'll be creating the machines, not you manually. And when the template is set up, the MIG can be creating the machine. So now let's take a look at setting up a containerized managed instance group. So same thing we did with the instances, but now we're going to go with a group of them. So we start with creating a template. And of course, the interface for creating a template is very similar to the interface for creating an instance, because it's basically a description of how to put together an instance. So you can see the same checkbox to grab your container. And we'll grab the same version, open up the port 80, and run that same Python front-end script. Allow the firewall pass-through for HTTP, and create. And of course, the difference is that when we hit create, nothing actually got created in terms of instances. It's just the template that was created, so the descriptor. And from the template now, we can say, OK, I want you now to create multiple instances, so create a group of these for me. And so this is a second flow into how to create groups. The other main flow is to create a group from the instance groups tab on the left side, but you can also create a group directly from a template. So now we'll give our group a name, and we'll call it next containerized instance group 1. Leave the single zone and choose same US Central. The template is already selected, and now we're going to go with 10 instances. Hit create, and we're good to go. So now the group itself is being created, and as soon as it becomes a resource, we can hook it up to a load balancer. Because now that we have 10 machines, obviously we want to have a single IP that can be accessed by the users. And so we don't want to have 10 individual instances. So the group is being created, the instances are being created, and now we can tab over to networking and load balancer. And choose one of the load balancers that was created previously, but it's empty, as in there's no backend. So right now, that load balancer has no target to send traffic to, and we can now, from a dropdown, select the new managed instance group we just created, next containerized IG1, hit update, and networking will get connected. Just make sure that the instances are all created, so we can check each individual instance whether it's serving, and yes, it is. If we go direct, and go back to our load balanced IP. And it takes a second or 3 to connect through networking. And there it is, and there you go. So now the traffic that went to the load balancer IP got passed through to one of the containerized instances, and it all works just like we kind of expected. Great, so that worked really nicely for that setup. We have one machine, then we scale up to 10. We connected it to a load balancer. Everything's good, but now our service is a little bit exposed to potentially going down. And there are typically 2 things that can bring your service down. So one, there is that concept of a zonal outage, right, where all of these instances we put into that one US Central C1, I think, zone. And if that zone goes down or has an outage or has some networking problems, then your whole service is down. And then 2, which is quite frankly more likely, is your software might have an issue or the machine might start crashing and your service will slowly start experiencing machine-by-machine outages. And that's what AutoHealing can help with. So now that you're in this managed instance group, you can easily deal with both cases. So let's take a look at the zonal problem first. Instead of a regular MIG, you can create a regional managed instance group. The main difference is that the regional MIG will split your instances into zones proportionally and make sure that they're always balanced in terms of their number of instances as you're scaling up and down. So you don't have to worry about doing that kind of balancing yourself across the different zones. You just pick a region, and we'll make sure that you have the right amount of instances per zone. So if there's an outage, you're protected. But there's a bit more detail to this. So let's imagine this case. You have 3 zones. You have your 10 instances, and they're serving, and you're happy, and then zone A goes down. Well, now those 3 instances have to be reallocated to the other zones. But if a zone really did go down, you might have a lot of people trying to do the very same thing, which means that at the time when you need it most, you might be not getting any of instances because of stockouts. So that's why the best practice we advise is to actually over-provision or create additional machines that you don't strictly need to serve the traffic you have now, but that you can use when there's an outage. And the best practice is to provision basically 50% more machines per zone. Now, why 50%? If you have this case and you've got your 3 zones and you have 10 machines that are serving and you have some extras, if zone A goes out, those 3 machines have now somewhere to fail over into or have that traffic be served by other machines, which is great. But of course, the machines you over-provisioned in zone A are now offline as well. So that's why you kind of have to have more in the other zones. So that works really well for that kind of zonal outages, and now you're more highly available, which is great. But for certain use cases, even that might not be enough. And you might start looking at cross-regional availability, which is out of the scope of this talk, but there is a really good talk that happened yesterday, IO204, Designing Reliable Systems with Cloud Infrastructure, which goes into great detail of kind of global availability and how to think about that. So check it out if you want to know more about how to protect yourself from outages. OK, so that was the zonal part. But I did mention that it's more likely, actually, there might be software or machinist issues. So let's look at auto-healing and health checks. Now, a health check is really just a simple method of determining whether your machine is healthy. That's all it is, which typically means you ping it on some path with a certain frequency, and at some point you determine that a machine is not healthy or needs to be healed or restarted or something. And both the load balancer and the auto healer use health checks. Now, there's an important thing to keep in mind. These services actually have a very different use for the health check. So while they're both health checks, when a load balancer is using a health check, and one of the machines reports as offline, it'll just stop sending traffic to that machine. So the health check, the way the load balancer thinks about it, is kind of like a busy signal. Right? The machine says, I can't handle any traffic anymore, I'm not responding. The load balancer says, no problem, I'll stop sending you traffic. When the machine comes back online and starts passing its health checks, the load balancer will resume sending traffic. So that health check can be fairly aggressive in determining machines to be unhealthy, because the cost of going unhealthy is just, hey, this one machine temporarily stops receiving traffic and then can resume. Auto healer is different. When a machine goes unhealthy and it's an auto healing health check, the auto healer will recreate the machine, which is a much more disruptive occurrence. So it does mean that when you're designing your system, you want your auto healer health checks to be more conservative, so that you only trigger if the machine truly is down, and you want to make sure that it gets recreated and basically healed. OK, so now let's put it all together, and let's create a regional managed instance group with auto healing and load balancing and containers. So we start with the health checks. So let's create 2 of them. The first one will be for the auto healer. So we'll call it next simple HC-AH. And for our little app, we do the health check on /health check, just so it's easy to remember. And we'll leave these parameters as they are, basically. So the check interval is 3. And we can change the timeout to 3. And what that means is that the health check will be triggered every 5 seconds, and we'll wait 3 seconds for a response. But what we're changing is the threshold to be 3 as well, which means that it takes 3 fails for the instance to become unhealthy, right? And we're checking every 5 seconds. So it's a 15-second duration, right? So it'll basically check, wait 5 seconds, check, wait 5 seconds, check, wait 5 seconds, and then go, OK, you're unhealthy. For this other health check, the load balancing one, the LB, we'll use the same path, right? So the key is that the actual health check point, like the ping, the heartbeat, could be the same. All we're playing with is the how aggressive or conservative it is. So this one is a bit more aggressive. So it's every 3 seconds. And here the error is that the timeout is 5, right? So you can't ping more frequently than you're waiting for a response, obviously. So we're going to ping every 3 seconds, and we're going to just wait for 2 responses, which means that it'll take 6 seconds to flag an instance as unhealthy for load balancing, right? Which is basically like less than half of our auto healing case. And that's what I meant, right? Is that the load balancer can kind of more quickly say, hey, I'm not going to send you any more traffic, but the auto healer will wait a little bit longer before it clobbers that machine and recreates it. OK, so now we're creating the instance group. We'll call it next RMIG containerized 1. And to make it containerized, all you need to do is toggle this little switch called make it multi-zone. Choose US Central, let's just keep it in the same place, but now you're selecting a region, right, not a zone. So it'll use the 3 zones in that region. We'll select a template, call it instance template v1, and let's do 12 machines because, I don't know, 12 divides into 3, so we can have 4 machines nicely. Hit create, and there you go, and that's all you needed. So that regional managed instance group resource is getting created, and then as soon as it becomes live, we can start connecting networking to it. All right, click in, and the one thing you'll notice is you have that list of machines getting created, but now you can see that they're split across 3 zones. So you've got the C, F, and B in there. Now we'll go over to load balancing, just like we did before. And edit the backend to select the newly created RMIG containerized 1 regional managed instance group. And that's kind of all you have to do. Just select it as a backend because that's what it is. And the difference from last time is now we're going to select that health check that we created. So let's find it. Next simple LB for load balancing. So we want to make sure that we grab the right health check here. Hit update, and that's it. And then just make sure that the instance is now got created. And the one thing that we didn't do previously, so let's fix it now, we didn't actually select the auto healer health check. So let's set up auto healing. So all you have to do is in your managed instance group, and you can do this at create or afterwards, you select the health check. And then you can also select an initial delay. So that's basically the amount of time that the auto healer will wait before it starts testing an instance after the instance gets created. So it lets your instance boot up and become ready before it starts getting potentially clobbered, right? So you don't go into this cycle where it keeps on auto-healing and recreating. So the instances are serving. So now let's go to networking and check that IP that's been load balanced. That's shared amongst all of the 12 instances for receiving traffic. Hit refresh, and there we go, and we're serving. So we're good, we're up. So we have that first part down, right? Out of the cycle, we did that cycle once. So we wrote some code, we built it into a container, we tested it, we deployed it, we're serving, we're happy, we're good, we're ready to go home for the weekend, and then it turns out, hey, version 2 dropped in. So now you have to update this. What are your options? Well, in the past, you had basically 2 things you could do, and both of them were kind of manual. So one of the option is to, OK, let's do all of this again. Let's create a regional managed instance group with version 2, and version 1 is serving. And now we'll live reconnect the load balancing and hope for the best, and then disconnect the old instance group. And so it's all kind of, you're operating on these live instance groups, switching traffic. The other option is maybe you could change the template inside your first group and then force a recreate of all the machines. But then what about your availability, right? As you're recreating these machines, you're not serving traffic. So both of these options were somewhat workable, but a little bit painful. So that's why we introduced the updater. Instead of starting with exactly the details of the updater, let's just talk about what it does. So at the highest level, the concept is really simple, right? You have a version 1 blue, you want all version 2 green, and you just want to update your instance group without having to touch networking, without having to touch any other setups, but you still want that control. So let's start simple, and let's just do a simple update from version 1 to version 2. So we start with our managed instance group, and if we look at the details, we can see that we're split in across the 3 zones, 4 machines each. They're all in version 1, so everything's good. And now we click this new button called Rolling Update. And we currently have version 1. Select 2. That's our green build. Don't touch anything else. And hit Update. And there you go. The new version starts getting rolled out. Now you can see that actually 6 machines are being touched because what's happening is 1 machine per zone, so 3 in total, are getting destroyed, and 3 in total are getting created. So we're destroying 3 old machines and creating 3 new machines, 1 per zone, and we're rolling it out. And in the details, you can see that now we're saying, hey, I'm going to take your template 1, version 1 blue, to 0 instances, and your version 2 up to 12 instances because you're going from blue to green, all of them. Great, so that works nicely for that simple update where you have to go all version 1 to all version 2, 1 machine at a time, or 1 per zone. But real life isn't that simple, because what you really want to do is this. If you have a service that is live and you want it to be highly available, and you have a new version, and you probably tested it a lot, and you're pretty confident with it, you still don't want to roll it out 100% into your live production, just plow it in there and hope for the best. You probably want to do some sort of canary. Dip your toes, maybe roll out 1 machine in 1 zone, see how it performs, make sure that there's nothing crazy going on, and then go forward from there. So let's do a simple canary update with the system, where we start in the same place, all version 1s, same RMIG, 4 per zone, and let's go to rolling update. And the difference is we have the 12 blue machines in version 1. Let's add 1 in the new release. So we add a version 2, and we're saying 1 instance. And you can see that the system adjusted the count to say, well, we're going to have 11 in the old version and 1 in the new version. And then hit Update. And that's it. Whereas last time you saw 6 machines were being updated because we were going through all of them. Now it's just we're creating 1 and we're destroying 1, so we're replacing it. And in the details, you can see that we're targeting towards 11 and 1. So the updater is going to maintain that rollout because that's what you specified. OK, so that worked well for the 1 machine. And let's say you deployed it and tested it and it works well. So now you want to say, maybe let's test performance. But in order to feel good about performance, you want to have a larger rollout. So let's roll out a third, or 33%, into your instance group. And you're starting with that single machine rolled out, which is in 1 of the zones, and it's serving fine. And when you go to rolling updates, all you have to do is say, OK, well, instead of 1 instance, now I'm going to think about percentages, because I want to have a third, whatever the size of my group. I'll put in 33 for a third, and don't touch anything else, and hit Update. And so for that rollout, what you can see now is the updater will create the missing machines, so it leaves that 1 you already updated. And in the details, you can see that the target size, what it's going to, is a third in your new version. So it's basically targeting that 1/3 Canary rollout, and you can check on its progress and what the target size is. When it finishes the update, you can run your performance tests and then either roll forward or roll back. OK, so let's stay focused. We're doing really well. Let's keep going. We were skipping over these parameters. And they're actually that magic sauce that makes these updates configurable. So everything we've been doing so far was along the lines of, like, I just want to get these machines out there in a certain percentage. But there's more to this than you can do. The first thing you can do is, instead of rolling out your instances like we were doing proactively, where as soon as you hit update, they start getting created, you can be less disruptive. You can say, I only want to roll out my new version when the instances are getting created for another reason. Let's say your instance group is scaling up or scaling down. So that's opportunistic. So you can say, I'm only going to update on when the opportunity presents itself. Second parameter is maximum surge. Now, this is all about the concept of where is the update happening. It's the kind of the scratch pad. So if you imagine you have your serving set of machines, and you need to take them to a new version, maximum surge allows you to create a temporary scratch pad on the side where you can put up new machines without touching these old ones, the ones that are serving. So you put up new machines, and only when they're serving and confirmed as healthy, you take away the old ones. So it's like a temporary additional space. Maximum unavailable is all about this serving space, and it's kind of your disruption budget. So what you can say is, I want to update inside my serving space, but I only want to update like one machine at a time, or 2 or 3, or 50%. And so the two parameters together allow you to roll your updates out either affecting your existing serving space or not. And then the final parameter is maximum wait time, which is all about the rate of the update or how much testing you want to do. So if you want to, for example, not just go one machine after the other with 0 wait time, which is what we've been doing so far, but you want to say, I want to, for example, pause for 10 minutes between each machines because I want to have a really gradual, one machine at a time slow update, then you just put in, let's say, 10 minutes here, and after a machine updates and passes its health checks, the next one won't start for that wait time. So with all of these together, you can really configure the update exactly how you want it to be. And so, for example, like one of the opposite ways of from safety, because everything we did so far was this idea of a really slow and safe update. What if you have a critical fix or a fast rollback, and you want to update as quickly as possible, but you still don't want to affect your serving set? Then just set your max surge to 100% and set your unavailable to 0. And then what the updater will do will spin up duplicate machines in the new version, make sure they're healthy, and then destroy the old machines only after these ones pass the health check. So it'll do an update basically in one step, even if it is like dozens or hundreds of machines. And it's a way to basically not have to wait for the kind of rolling update. So with these parameters all together, you can get different effects. Can I switch to the computer, please? So for the last update, I'm just going to show the actual interface just to show that it is working. So if we, let's say, want to plow through version 2 as quickly as possible, then we change the instances to %, and so that'll be all of the instances that are going to be surging, so additional, no instances unavailable. So I don't want to touch my serving instances. I don't want to wait. Hit update. And what you can see is that all of these new machines in version 2 are spinning up at the same time, but the version 1s are not being touched. And the other important thing is, if you tab over to the details, you actually have 24 machines out of the 12. So we doubled up your capacity, which obviously means that you have to have the quota for it and you incur the extra costs, but it is temporary. It's only for as long as it takes for these machines to spin up and pass their health checks. So it might be worth it in certain cases. And in terms of the training, we're going to none of these and all of these. OK, can I go back, please? OK. One more concept with the thinking about updates that's kind of important. So when we were talking about the 1/3 rollout, because the managed instance group could have auto-scaling, you want that 1/3 to be maintained as you're scaling up, right? So that's an important consideration where an update isn't an action. That's basically you set it and you're done. An update is a target. Because if you want to have a third rollout, then you want that third to be maintained as you're scaling up and you're scaling down. So in this case, if 3 instances are getting added, 2 of them will be in one version and 1/3 will be in the other version. OK. That was a lot of updating. So let's think about one more thing. We talked about containers as a packaging thing. That's what we started our little example with, and that's what we worked with. And we talked about templates and changing them, and that's all good. But if you're using, let's say, startup scripts, you don't need to worry about templates. So none of this applies. And if you are using, let's say, baked images, and you have an image family where you just want to be recreating your machines and not touching the template and you pulling new images, again, that's not what you want. So there is also a restart recreate command where it's the same concept, same parameters in terms of control with max and available, minimum wait time, but you can just restart or recreate machines without touching templates. So I started this whole thing with the idea of managed and integrated features working together. And now you might be thinking, so OK, good. So you've got all these automations, and they're all doing their own thing. How do they interact? We touched a little bit upon the auto-scaling updating, but there's more detail than this. What about, let's say, auto-healer and updated? I talked about the disruption budget for the updater, and then there's the auto-healer. So what happens if you launch an update, and let's say you set your disruption budget to 5, because you can only afford to have 5 machines down at a time, and you set your max and available to 5, and then the auto-healer comes in and kills 3 machines. Well, the updater will know about this, so it will only use 2 machines while this is happening, because it understands that 3 are down for some other reason. When they get healed up and come back online, the updater will pick them up and now have its full budget of 5 to work with. So that works really nicely. So you don't have to mess with the auto-healer if you want to roll out an update, and you can still have your budget. But what about the autoscaler? This is a little bit trickier. If you have an autoscaler and you set it to a certain target threshold, and it figured out that it needs 5 machines to serve this traffic, and then you say, OK, I'm going to roll out a new update, and I'm going to take some machines down. So 2 machines disappear for update. That traffic has to go somewhere, and it'll be served by the remaining 3 machines. But of course, now they're well over their target load. And so you might ask the question, like, will the autoscaler freak out and start adding these machines? Well, no, because the autoscaler knows that those 2 machines are down for updates, and they're coming right back. So as soon as they show up, they'll pick up the traffic, and the autoscaler doesn't need to scale because it knows that it actually wants 5. Now, if in the middle of the update and actually there was more traffic, and suddenly the autoscaler thought, hey, I need 6 machines, then it would spin up additional machines. So it's not like it's paused. It's just including what's happening in its overall calculations. So that's the idea of it being an integrated system. And of course, all of the examples I gave you were with the UI, because it's kind of more fun to show, but it's fully supported by gcloud, so you can write scripts and use all of these parameters in gcloud as well. So let's put it all together. We talked about managed, and now you can set up a region managed instance group, which is resistant to traffic changes with auto-scaling, because you can add and remove machines based on whatever load you specify or however you think about load. You can be resilient to machines crashing with auto-healing. You can take new versions and roll out updates. And you can also be resistant to zonal outages with regional. So now I wanted to talk to you or share with you how one of our customers, Descartes Labs, used all of these features together in 2 of their specific use cases. Now, if you don't know who Descartes is, they're a machine learning specialist, and one of their big products is crop yield predictions and famine predictions based on satellite imagery. Now, like all machine learning, what they do this with is, unsurprisingly, a ton of computation. And in fact, they run tens and thousands of cores inside MIGs all day, every day to create these models. In practice, that means they actually ended up creating a managed instance group with 1,000 machines, and all of these machines are pretty beefy to chunk through the machine learning models. But the tricky thing is, when a new version shows up, they don't care about the old version at all, because there's no point running the old code when you want to have a new model. So when they're rolling out their update, their disruption budget is 100%. This isn't serving. It's basically a batch job that's just continuously running on new batches of data. So when you want to roll out a new version, you can do this all at once. And when they run this, basically all of the machines get updated essentially in one step, even though it's like 1,000 machines. So it's a really fast parallel update. Now, their other use case is a little bit more traditional. Once these models get created, they actually have to get served to their customers. And they do this through custom front ends. And these front ends translate the data in a way that's human readable, and their customers can use these. Now, they actually have 17 of these front ends. Each one is a MIG, and it's auto-scaled from 1 to 100. And when a new version comes out, all they need to do is just actually restart the machines, because they use startup scripts for their actual software. But because they're serving, they can't take them down fully. So in this case, based on when they're rolling out the new version, all they need to do is restart with a 10% disruption budget, right? Because that's based on their use case. That's not noticeable by customers, but it's also fast enough to go through all of the machines. And because there's 17 of these MIGs, they can do a scripted rollout with gcloud commands going one at a time. But because they're non-blocking, all 17 get submitted basically at the same time, and the MIGs update or restart in parallel. Now, if you want to actually know more about Descartes Labs and how they set up their systems, there is a great talk they did today, IO235, how Descartes Labs uses Postgres on GCP. And they also talk about a little bit more about their setup, so it's worth checking out if you're interested in that use case. So there you have it. We started with containers and deployments of easy container deployments on single machines or directly into MIGs. We looked at regional managed instance groups, which now can be split into zones, have auto-healing, auto-scaling, updates. And for updates, we looked at the new updater features, which give you a lot of flexibility and power with how you version or roll out new versions of your software to your machine, to your MIGs. If you want to get started or want to know more, there's plenty of documentation, and I think these slides will be shared, so if you didn't take great notes, no worries. And I just want to leave you with this final thought to bring it all together. Even if you want that kind of direct control of instances for your infrastructure, you don't have to do everything by hand. Build the service by choosing the managed features that work for you, and we'll help you out with managing your service. You're not on your own. Thank you very much. I think we've got some time for questions as well.